Okay, let's get started on a little warm-up exercise for the semester. Um, in Rhino, make sure that your units are set to inches, as you can see down below here. So make sure that your unit settings are set to inches. That'll be important later. And we'll get started. I'm going to go to Vector and create a grid, a square grid. And I'm going to plug in the following values, and we'll change them a little bit later. So I'll go with 9 in the X direction. This is the number of cells that we have in the grid. And 12 in the Y direction. You can see we're starting to draw that grid here on our screen in the top view. And for the size, I'm going to make this 0.65. Okay, kind of zoom in on that. And then because I don't really actually need the grid, what I'm going to use in this exercise is just the intersection points. I'm going to turn off the preview of this grid and use one of these point parameters up here, and just to show us the points of the grid. So we now have a point grid instead of a drawn grid of lines. Okay, and I'm going to start drawing objects along these each one of these grid points, using them as a center. So I'll head over to Curve, Primitive, and Polygon. And you'll see that as we do that, it's going to look a little crazy, and that's just because the radius is pretty big on this by default. We're going to adjust that. So we'll go over, grab a slider, over in Parameters, grab a slider. You should be all familiar with this from last semester. And I'm just going to make that 0.5. The number of sides we're going to change to 4, so we're going to make these squares. And later on you'll be able to experiment with this. These are just some base parameters for us to get started. And the fillet radius is a nice parameter here. We can kind of round off the square. And I guess I'll turn that down to like maybe around 1/8 inch. Let's do that. Yeah, so it's still a square, but it has a little bit of a rounded edge. I don't want to turn that into a circle. And let's take a quick look at what we've done here. We've used this component to draw a polygon in each one of these center points. And if we take a look at how that data is organized, we're going to come back to this at the end, but let's take a look at it now. What we can see is that we've got an organization of points that splits the overall number into a set of separate lists. So these numbers here are going to produce that number of points. So there's 130 points in this system. Depending on how Grasshopper chooses to organize how many, whether or not it organizes it in rows or columns, we'll say, is what will affect this data structure. Here, as you can see, what we've got is a set of 10 lists with 13 points on each one. So we'll get back to this, and this is going to matter in terms of the kind of overall effect that we get out of rotating these squares, and we'll get back to that in a second. So the first thing we're going to do is just going to start. We're just going to add a rotation component to these polygons, and I want to do that in a gradient. So what I'm going to do is just introduce you to a basic, one simple way of creating a range of values and then applying them to specific parts of the array of geometry to get a kind of a gradient effect from one side to the other. So we'll head over to Translate, and in Euclidean we'll find the rotate component. The geometry that we're rotating is the polygons, and you're going to see that by default it's going to put stuff over here. That's because the whole set is being rotated all together along the origin point by default, but we're going to change that by setting center points for each one. The rotation plane, we can actually just plug these points directly in. and that's already going to change what it's rotating. Now it's rotating each one of these individually instead of as a set. We just can't see that yet because this angle value is still pretty small. And what I want to do here is turn this from radians into degrees, so I'm just going to right click and turn on the degrees there. The other thing I'm going to do is turn off the preview of the polygon, original polygon, just so that we don't get confused. And then I'm just going to drop in a slider just as a prototyping, component, just so I can start seeing some effect here, just so I know that things are working. Yeah, and what we can see now, what we're doing is rotating each one of those squares, and we're starting to produce kind of a nice overlap. There's a pattern kind of emerging in the overlap themselves if you focus on these regions here. And that's going to be one of the things that we're going to do in this assignment, is use these simple geometries and the numeric control over the geometry to produce, in the end, what I think could look like a very nice and relatively complex pattern. Okay, and we're going to replace this slider with now a range of values. Here, the same angle value is being applied to every single square. But what we want to do instead is apply a different angle value to each row, each column, for example, or the entire set, meaning that each one of these squares individually will get a different rotation value. So let's experiment with that. I'm going to head over to Set, go to Sequence, and Series, and grab the Series component here. Now what we need to do is tell this component how many numbers we need, and we're going to gather that information from how many points we have. So we're going to go over the set here, still list and list list length. And you're going to plug the original point set into that, and I'm going to move this down a little bit to give me some breathing room here so you can see it a little better. And now the output of this is going to give us the length of each one of those lists individually. And we can just plug that in there, and now we got a series of, and you can see now that our data structure coming out of this component matches the data structure that we just inherited from the input of the points. That's good. What we want to do is pay attention to the way data is matching downstream. Here is an important, this is going to be the size of the angle difference between each step. So it'll start at 0, and then in this case we'll go to 0.25, and then 0.5, and so on. So let's plug that in. Let's take a look at our values. And you can kind of see what I mean here. So as this number increases, these values will also continually increase. I'm going to change this to 6.5. And you might need to adjust your slider to allow those values. So I'm just going to change my maximum here to, I guess, to 10. Put in 6.5 because this is a value that I've experimented with a little bit and I think works well for this example. And the starting value can remain at 0 because maybe we want to keep the first item in the set as a 0 rotation. We can now replace, because our data streams match up, we can kind of see the structure here at the bottom there. You can see that we've got still 130 numbers, and it's organized into 10 lists of 13, and that's of course true over here as well. So we want to make sure those things match up before we plug that in, and you can now see the effect. So we've got a rotation of 0 applied to this row, a rotation of 6.5 to that row, 13 to this row, 19.5 to that row, and you get the idea, and so on we go. All the way up to that portion here, which will end up looking pretty similar with a 78 degree. Although I guess it's not, sorry, it's not similar. It's different than the one down here. And there are ways to get that symmetrical that we won't cover in this simple exercise, but I think you get at least some of the idea here. If we reduce this, you'll start to notice a more subtle effect or a more maximum effect. So I'm going to leave this at maybe at 7 or something. I guess that's okay as well. Zoom in a bit, maybe I'd make an adjustment. See what happens if, yeah, maybe I can get that a little closer. Let's try 7.25. Yeah, that looks pretty even. Great. So just with a simple rotation, a serial rotation, applied to an array of objects, you can start, controlling a large grouping of geometry. And let's go back to this. We talked a little bit about the structure and how this works. Let's right-click on this now, just to see what the effect is if we flatten this list into a single grouping. So now you can see that the data, all the points, are now organized in one set, in one big list. And the organization of that list appears to be, well, actually, I don't know. We'll check for that in a second. It's either going to count this way or that way. I think it's counting up and then back again. So it's probably starting at 0 here, and then 1, 2, 3, 4, 5, whatever, 13, 14, 15, 16, 17, or whatever, and so on and so forth, up and down, up and down, up and down, because that's how it seems to be organizing it. But you can see now how the numbers are being applied. So none of this has to change down here. We're still getting, a grouping of rotation values that are different from one another. And it's okay that they increase past 360. It's just going to rotate more than once. So rotations of 935 degrees, for example, will rotate roughly 3 times. But because it's a proportional shift, you'll see a smooth gradient taking place here. And now you can go ahead and make adjustments also to this, and you'll start seeing different patterns emerge. And this is going to happen a little bit more quickly, just based on the size of our slider here, in terms of its max value, but you can start going slowly with it and playing around with how that works. And what's nice is that at some point you start to read, a change, maybe vertical striping, which starts to, kind of look more like this kind of diagonal striping at some point as the values increase. And now we get something that appears to be more, right, I guess a more horizontal striping, just because of the kind of shift that you see in this direction. And then back again. Now it's, at this point, it's kind of a little bit chaotic. But I guess if you look carefully enough, you'll see some gradients happening. So, go ahead and experiment with this sample file and see if you can get some really nice patterns to emerge. Of course, you can make changes to the number of sides of the geometry. This is basically a triangle. And in that case, what you may have to do is make a few adjustments over here. I'll go back to what I had before. Yeah. And maybe change the radius. There we go. Get some more overlap. And you'll see that as you start to make changes to the number of sides, you'll have to adjust to get, because what you're going to want to see is a little bit of white space in between the pattern. You're not the different objects in the pattern. You're not going to want full overlap like this, because it's difficult to determine later what you want to cut out of this.